three particles, each of mass m and carrying a charge q each, are suspended from a common point by insulating massless strings, each of length L. Okay. If the particles are in equilibrium and are located at the corners of an equilateral triangle of side A, the charge q on each particle, assuming L much greater than A, will be. So we have to find the charge. If these three particles are suspended through three different strings from a common point, then because of the electric repulsion, they will form a equilateral triangle at the bottom. And here in this video, I have shown the forces acting on one of the particles. As you can see, here somewhere is the common point. You can see this video again. So from this point, all these three charged particles are suspended. And how they are located at the corners of a equilateral triangle because of the electric repulsion. As here in this frame of this video, you can see that the forces acting on any of the charged particles are, first of all, these are two electric forces which are acting along the side of the triangle formed by the particles. Okay, because the particles are having the same charge, so they are repelling each other. So electric force of repulsion on any of these charges will be F, and from both the charges will be along the sides of the triangle. So angle between these two forces must be what? 60 degree. And since these two forces are equal, so their resultant must be along the bisector. Their resultant must be along the angle bisector. And if we apply the resultant formula, a square plus b square plus 2ab cos theta and whole under root, then what will you get? You will get F under root 3. If F is the electric force of repulsion from any of the particles, then F root 3 will be resultant electric force acting on any of these particles. As you can see that T tension is here, and suppose the string makes an angle theta with the vertical. Here this particular string is making an angle theta with the vertical, then vertical component of the tension here is going to be T cos theta, and horizontal component is against this resultant force, which is T sin theta. I have taken two components of this tension which are along the vertical direction, and one component is against the resultant of these three. So this particular plane must be passing through the centroid of the triangle. Here on this vertical line somewhere there must be the triangle center of this particular triangle. So here you can see clearly that this is mg, the weight of the body. So T cos theta must be balancing the weight of the body mg, and T sin theta must be counterbalancing the net electric force acting on any of these three particles. As if you see this particular diagram from this direction, what will you get? You will get this. Here you can see is the tension along the string, and this is upward component of tension, which is T cos theta, and here it will be the horizontal component T sin theta. It is weight of the particle, and this is the resultant force F root 3, the resultant electric force. And this is the top view of this arrangement. Here you can see that these are electric force of repulsion acting on all the particles, and their resultant is going to be F root 3. Weight of the body is acting perpendicular to this plane of this particular diagram, as you can see here. Mg is acting vertical. So these are the forces. So by dividing these two, what we get, tan theta is equal to F under root 3 divided by mg. As here you can see that L is assumed to be much greater than A. That means if you see this particular diagram, in this diagram here L is the length of the string, and this is the point which is basically the center of the triangle, this particular point, because this diagram is indicating this particular triangle which is made out of this line passing through the vertex of the triangle and center of the triangle, and this is the string and this is the vertical line. So this particular triangle is shown here. So this distance is the distance of the vertex from the centroid of the triangle, which is A by root 3. You can easily calculate this particular distance of the corner of the vertex of the triangle from its center. This particular angle is theta. So here you can see that sin theta is equal to A divided by under root 3 into L. And since L is much greater than A, so theta must be very small angle. So this sin theta must serve the purpose of tan theta also, because theta is going to be very small. So here we can substitute all these values. In place of tan theta, we are going to substitute A divided by L root 3. So in place of tan theta, I am going to substitute A divided by L root 3. And here F is the electric force, which is 1 upon 4 pi epsilon naught into Q1 Q2, which is Q square divided by A square, F electric, and this is root 3 and divided by mg. So on calculating this, what are we going to get? So we are going to get Q is equal to under root of 4 pi epsilon naught A cube mg divided by 3L. So this is the answer. The charge on any of the charged particles will be this. So option B will be the correct choice for this question.